looked up at the night sky and wondered, where is everybody? This simple question is at the heart of the Fermi Paradox. Named after physicist Enrico Fermi, this paradox addresses a puzzling contradiction. On one hand, we have a vast universe with billions of galaxies and trillions of planets. On the other, we see no signs of alien life. The math suggests that alien civilizations should be common. Yet we haven't found a single one. This silence is deafening. Are we alone? Are we first? Or are we missing something crucial? These questions have puzzled scientists for decades. The answers we find could reshape our view of the universe and of ourselves. Let's talk numbers. The universe is big, really big. It's almost incomprehensible. Our Milky Way galaxy alone has over 100 billion stars, each potentially hosting its own planetary system. And there are billions of galaxies in the observable universe, each with its own billions of stars. That's a lot of real estate for life to develop, evolve, and thrive. Even if life is rare, the sheer number of planets makes its existence somewhere in the universe highly likely. Recent discoveries have only strengthened this view, revealing more about the cosmos. We found thousands of exoplanets, each with unique characteristics. Many are in the Goldilocks zone where liquid water can exist, a crucial ingredient for life. Water is key for life as we know it, providing a medium for biochemical reactions. And where there's water, there might be life, hidden beneath the surface or in vast oceans. The odds seem to be in favor of life existing elsewhere, given the vastness of space. But it's not just about planets. It's about time, too. The universe is old, around 13.8 billion years. Life on Earth appeared fairly quickly after the planet formed, suggesting a natural tendency for life to arise. This suggests that life might be a common occurrence when conditions are right, given enough time and the right ingredients. Over the years, scientists have proposed many solutions to the Fermi Paradox. These fall into three main categories: distance, time, and technological limitations. Let's break them down. First, distance. Space is vast. Even at the speed of light, it takes years to reach the nearest stars. Maybe alien civilizations are out there, but too far away to contact. Time is another factor. The universe is old, but civilizations might be short-lived. Maybe we're not hearing from aliens because we're not listening at the right time. Technological limitations are the third category. Maybe we're not advanced enough to detect alien signals. Or maybe aliens are using communication methods we can't even imagine. These traditional solutions all have merit, but they also have problems. Imagine a dark forest at night. It's silent, but you know it's full of life. Animals are hiding, afraid to make a sound. Why? Because predators are listening. This is the essence of the dark forest theory. It suggests that the universe is silent because civilizations are hiding. They're afraid of being discovered. The theory comes from science fiction writer Liu Cixin, but it's based on game theory and real-world observations. In this view, resources in the universe are limited. Any advanced civilization could be a potential threat, so the safest strategy is to stay quiet and hidden. Making your presence known could be a death sentence. This theory explains the silence we observe. It also explains why we haven't been contacted. The Great Filter hypothesis is another attempt to solve the Fermi Paradox. It suggests that there's a barrier that prevents life from becoming advanced. This filter could be at any stage of development, from the emergence of life to the development of intelligence, or even in our future. If the Great Filter is behind us, that's good news. It means we've passed a major hurdle. Maybe the formation of life is incredibly rare, or maybe the jump to multicellular organisms is the big challenge. But what if the Great Filter is ahead of us? This is a more troubling possibility. It could mean that something prevents civilizations from becoming spacefaring. If this is true, our future might be bleak. These theories about the Fermi Paradox have profound implications for us, touching on both our existential questions and practical concerns. They force us to confront our place in the cosmos and to think hard about our future, our survival, and our responsibilities. If the dark forest theory is correct, should we be broadcasting our presence? Are we putting ourselves at risk by revealing our existence to potentially hostile civilizations? On the other hand, if the Great Filter is real, what does that mean for us? Have we already passed it, or is it still ahead? Should we be focusing all our efforts on survival, on solving global problems like climate change, or on developing advanced technologies to help us pass whatever filter might lie ahead? These are critical questions. These are not just academic questions. They have real-world consequences that could affect our policies and priorities. They could shape the future of our species, influencing how we approach space exploration and international cooperation. These theories also impact how we view ourselves, our uniqueness, and our role in the universe. If we're alone, or one of very few civilizations that makes us special, and perhaps even more responsible for the stewardship of life in the cosmos. Despite these sobering theories, we haven't given up the search for extraterrestrial intelligence. SETI, the search for extraterrestrial intelligence, continues its work tirelessly. They listen for radio signals from space, hoping to catch a whisper from another civilization. They look for signs of alien technology, scanning for anything that stands out. Their work is based on hope and curiosity, driven by the desire to answer one of humanity's oldest questions. New technologies are expanding our search capabilities, making it possible to explore deeper into space. We're building more powerful telescopes, capable of detecting even the faintest signals. We're developing better ways to detect exoplanets, those distant worlds that might harbor life. We're even considering sending tiny probes to nearby star systems to get a closer look. These efforts might help us solve the Fermi Paradox once and for all, answering why we haven't found evidence of other civilizations yet. But the search isn't just about finding aliens. It's about expanding our knowledge. It's about understanding our place in the universe and what it means to be part of this cosmic tapestry. Every new discovery, even if it's not alien life, teaches us something valuable. We learn about planet formation, the birthplaces of potential new worlds, about the conditions necessary for life, and what makes a planet habitable, about the vastness and complexity of the cosmos and our place within it. Pause 2S. Ponder the many theories and possibilities of extraterrestrial life. Our quest to uncover the unknown continues to evolve. The future of our search for intelligent life in the universe holds exciting potential. Advances in technology are opening new frontiers, offering us tools and methods that were once the stuff of science fiction. One of the most promising developments is the rise of quantum computing. These powerful machines could process the vast amounts of data collected by our telescopes and probes far more efficiently than traditional computers. With quantum computing, we could analyze signals and patterns that might currently be too complex for us to detect. We are also exploring new ways to communicate. Laser communication, for instance, offers a faster and more efficient method for sending messages across the cosmos. By using laser beams, we could potentially send and receive data at the speed of light, drastically reducing the time it takes to communicate across vast distances. Moreover, the development of artificial intelligence is playing a crucial role in our search. AI algorithms can sift through enormous data sets, identifying anomalies and potential signals that might indicate the presence of extraterrestrial technology. By leveraging AI, we can enhance our ability to detect even the faintest whispers from distant civilizations. Another exciting prospect is the expansion of our observational capabilities. Projects like the James Webb Space Telescope and the upcoming Extremely Large Telescope will allow us to peer deeper into the universe than ever before. These instruments will provide us with unprecedented views of exoplanets and their atmospheres, helping us to identify potential signs of life. But beyond the technology, our search is also guided by a sense of unity and purpose. The quest to find extraterrestrial life is a global endeavor, bringing together scientists, researchers, and enthusiasts from all corners of the world. It is a collective effort driven by curiosity, wonder, and the desire to understand our place in the universe. As we continue to push the boundaries of our knowledge, we must remain open to the unexpected. The universe is vast and mysterious, and it may hold surprises that we cannot yet imagine. Whether we find evidence of other civilizations or not, the journey itself is a testament to the indomitable spirit of human exploration. Look to the stars with hope and determination, knowing that every step we take brings us closer to answering one of humanity's oldest and most profound questions. Are we alone in the universe? Until that day comes, we will continue to listen, to watch, and to dream. For in the pursuit of the unknown, we discover not only the secrets of the cosmos, but also the boundless potential of our own humanity. There's no use asking why it would do this, all that matters is that it can. But aside from this horrifying thought, would it know when it has reached the singularity? We must also turn our gaze inward, to reflect on what this search for extraterrestrial life means for us as a species. Beyond the scientific and technological pursuits, there lies a profound philosophical journey. Pause 1s. What does it mean for humanity if we are truly alone in the universe? The implications are vast, touching on our understanding of existence, purpose, and our place in the grand tapestry of the cosmos. If we are alone, it may suggest that life is an incredibly rare and precious phenomenon, placing an even greater responsibility on us to cherish and protect our fragile blue planet. On the other hand, discovering intelligent life elsewhere would be one of the most transformative moments in human history. It would challenge our notions of identity, culture, and the very essence of what it means to be human. We would have to reconsider our philosophies, religions, and the frameworks through which we interpret the world. Pause 1s. The search for extraterrestrial intelligence also raises ethical questions. How should we approach potential contact? What responsibilities do we have towards other civilizations? And how do we ensure that our quest does not inadvertently harm the very beings we seek to find? Pause 1s. These questions are not just academic. They compel us to think deeply about our values, our aspirations, and the legacy we wish to leave for future generations. They remind us that the quest for knowledge is intertwined with the quest for meaning. We must also nurture the spirit of curiosity and wonder within ourselves. For it is this spirit that drives us to seek answers, to push boundaries, and to dream of what lies beyond the stars. In this grand endeavor, we are united by a shared sense of curiosity and a desire to understand the universe and our place within it. Whether we find other civilizations or not, the search itself is a testament to the boundless potential of human imagination and the enduring quest for knowledge. Pause 2s. So as we gaze into the night sky, let us remember that as important as the destination. For in seeking to understand the cosmos, we may ultimately come to understand ourselves. Pause 1s. Thank you for joining us on this exploration. Stay curious, stay hopeful, and keep looking up. Until next time.